I still don't know what to explain for the breakthrough challenge. It is so confusing. Let me at least watch the sunset. That's amazing! Yes! I got the perfect topic for the Breakthrough Junior Challenge. Why does a green flash occur? Dispersion. But why does dispersion occur? Refraction. Refraction is the bending of light when it enters obliquely from one medium to another. This happens because light travels with different speed in different media. When light travels from a less optically dense medium to a more optically dense medium, it refracts towards the normal. But when light travels from a more optically dense medium to a less optically dense medium, it refracts away from the normal. Vacuum has the least optical density, and hence light traveling from vacuum to any other medium always refracts towards the normal. I believe that doing experiments is the only way that one can understand concepts. So let me do this simple experiment. Let us take a transparent beaker filled with water and a straight pencil. When you dip the pencil in the water, you see that the pencil bends. But when you take it out, the pencil is no longer bent. In water, the pencil appeared to be bent. This is because light from the pencil got bent while traveling from water to air. What is dispersion? I guess you know that white light is made up of 7 colors, the famous colors found in a rainbow, Vibgyor. The splitting of white light into its components is called dispersion. Dispersion is actually a consequence of refraction. Different colored lights refract through different angles due to different wavelengths. Lower wavelength lights like blue and green tend to refract the most. Now that we know about dispersion and how it is caused by refraction, let us try to understand the green flash phenomenon. The green flash occurs due to the Earth's atmosphere. How? Well, the Earth's atmosphere is more optically dense than vacuum. Therefore, it acts like a prism to disperse the light from the sun. The light from the sun gets refracted by the Earth's atmosphere, and hence the sun that we see is just an image of the actual sun. It is called the apparent sun. This shift is noticeable because there is not one refraction but multiple refractions due to the different layers of the atmosphere, which increases in optical density as we approach the Earth. As smaller wavelength lights get bent most, the top portion of the apparent sun is bluish green. You can start noticing a green color at the top corner of the sun. The apparent sun is disappearing into the horizon, and that is a perfect green flash. Is this green color always present? Yes, no matter where the sun is, the sun that we see is the apparent sun, and the top portion of the apparent sun is always green. But the intensity of the orangish red light of the sun is so high that it overlays this green color, preventing us from seeing it, except during sunrise and sunset, where the horizon shields us from this high intensity light and allows us to see the green color as a green flash. Why can't you and I see the green flash during all sunsets and all sunrises? Why is seeing this a rarity? It's because there are conditions to view this phenomenon. 1. This can be viewed only when you can see till the end of the horizon, like at a beach or on a mountain. This is because only then would you be able to see the last bit of the apparent sun disappearing or appearing. It can be viewed only in a place where there is no pollution and the atmosphere is clean. There must also be no clouds. This is because if there are pollutants, the green light could get scattered away and you will not be able to see the green flash. Despite one meeting these conditions, it is still extremely difficult to view the green flash. Please bear in mind, the green flash lasts only for a few seconds. At the time of sunrise, we would need to know the exact location and the time when the sun would rise. Even if we have timed it well and expect the sun to rise from here, it could even pop out from here. At the time of sunset, if you look at the sun before it is almost entirely below the horizon, you may dazzle your eye and miss your chance of seeing the green flash that day. Signing off. I'm Siddharth.